Okay, so we have here, we want the limit as n goes to infinity of Rn over n factorial, where r is positive. We want to prove that that's equal to 0. So what we're allowed to do is we can skip the first few terms. So since we're looking as the limit goes to infinity, we are free to start at any point in the sequence, and that won't affect the limit as n goes to infinity. So we skip the first few terms, i.e. start at n equal to round up whatever the value of r is to the next integer. So for example, if r is 2.1, then you would start at the third term. So we want to prove now that if we have the sequence un equal to Rn over n factorial, where n is greater than or equal to n, we want to prove that this is decreasing. So we want to prove that un plus 1 is less than un, where n is more than or equal to n. So that means Rn plus 1 over n plus 1 factorial, that's less than Rn over n factorial. Doing a bit of cancelling here, can cancel that with that and cancel that with that. So you're left with r is less than r over n plus 1 is less than 1. So that would mean that r is less than n plus 1, or that n is more than or minus 1. Now, this is clearly true because n has to start at capital N, which we said is the value of r rounded up. So this is true since n is more than or equal to n, which is just r rounded up. Okay, so two things. One, un, where n is greater than or equal to n, is decreasing. Two, un is a positive because r and n are positives. The MCT theorem, monotonically convergent theorem, says that if a function is monotonic it's bounded, so in this case here all the terms have to be positive and it's decreasing, well then that means it has to be decreasing to 0, so that would mean that the limit is 0, so i.e. the limit as n goes to infinity of Rn over n factorial, that has to be 0 then. Okay.